All right, this video here is for problems like displacement and distance, but for the most part, distance, okay? That appears a lot. So remember, a quick refresher. When you integrate speed, you get total distance. You don't care about the direction that you're going in. You're just counting the number of steps that you took to get to your location, okay? Displacement, remember this visual here, displacement doesn't care about what happens during your trip. You're just finding out where you started and where you ended. Okay? So here we go. Let's go ahead and work on 2011 here. And I'm going to go ahead and get rid of a few of these things here. And again, you don't want to work on the packet for these, especially because you don't have a lot of space. But I want to make sure that the problem is still visible there. Okay, so here, find the total distance from 0 to 6. Very simple to do. This is a calculator active question, right? So what we want to do here is, before we use our calculator, we want to integrate the speed, which is the absolute value of v of t, which in this case is y1. Okay? And we're going to go from 0 to 6 because that's what it's asking us to do. And then it's a simple plug and chug. Now, I assume that your y1 is already programmed to v of t here, okay? So some things that you want to do. So in order to get to the integral, you're going to go to Math 9, okay? Math 9, and then you're going to go from 0 to 6. Now, to get to the absolute value, you're going to go to, I'll write it down here, you're going to go to Math. You're going to press the right arrow, and then it'll be the number 1. Or you can just press enter, okay? And then inside the absolute value, you're going to put alpha trace y1, and then dx, okay? A lot of plug and chug there, okay? If I had to guess, maybe that's a 1 or a 2 point question, okay? But go ahead and do that. Press play whenever you have your decimal. And let's take a look. 2011. Okay. So there you go, distance. And you don't have to write distance. You could just write the integral of the absolute value of v of t dt from 0 to 6 equals, and then they have their rounded answer there. 1 point for the entire integral, so that includes the integrand and the bounds, and 1 point for the answer. Easy 2 points to take care of there, okay? So if you think about it, total distance along with a speed question, that's already your bare minimum, or maybe even a little bit more. Pretty easy to do, okay? All right, let's take a look at a few that are slightly different. Let me see if I can find one. Well, you know what? I'll have one for you guys to try first. Okay. Okay, go ahead and just pause the video here and work on 2003, part C. Press play when you're ready, okay? Okay, so as of this point, I assume you should have programmed y1 to be v of t. Now remember, if you write y1 on your paper, on your AP exam, make sure that you declare it. Make sure that you say, let y1 equal v of t. So that way you could use the y1 symbol, okay? In this case, this is just the integral of the absolute value of v of t, or y1, if you declared it, from 0 to 3. We're finding the total distance from 0 to 3. This is a quick plug and chug. Let's take a look at the scoring guideline. 2003. If I can find it. Okay, here we go. 2003. Now, they did a lot of... Wait, was it 2003? A, okay. 2003A, number 2. That's 2003 Form B. Here we go. Okay. They were very generous in this one. Again, you don't have to write distance, remember. Setup and answer. You either truncate or round your answer. I think more people are comfortable with rounding. But here they're very generous. They give you 1 point for the limits, which are the bounds. They give you 1 point for the integrand, which is the absolute value of v of t, or the absolute value of y1, and 1 point for the answer. There's your bare minimum without even having to do the other ones. So total distance, just remember, is the integral of speed. Okay? With distance, you don't care about direction, so absolute value gets rid of the direction, okay? That pops up a lot, all right? Okay, so one more that's a little bit different, but not really. Okay, so take a look at, we'll do the entire part A here, because it still serves the same purpose. In 2005, we're going to do part A. It says, find the integral from 0 to 24 of v of t dt. And in this picture, we have the graph of v of t. So this is where you got to be really making an effort to connecting the dots here, okay? When you're integrating v, and this is the graph of v, don't forget that integrating means that you're finding the area of, right? Notice how you can't use a calculator here. It's number 5. It's not calculator active. But you do understand that integrating means finding the area under the curve. And this is very conveniently a rigid shape. Go ahead and find the area under this curve. Okay, so look. This is a trapezoid. Some of you might have cut it into 3 pieces. Some of you might have cut it into a triangle, a rectangle, and another triangle, right? Either way works. I'm just going to go ahead and take the easiest route, which is a trapezoid. So a trapezoid is really, so the integral from 0 to 24 v of t dt is really just 1/2 the height. So since the bases are parallel to each other, the bases will be a length of, that looks like from 4 to 16, that's 12. And from 0 to 24, that's 24. I know that my height will always be in between the 2 parallel lines. So here, it looks like I'm going from 0 all the way up to a y value of 20. So my height is 20. Right there, equal is equal. You can stop there. You get your point, okay? But let's go ahead and take care of this here. Using correct units, explain the meaning of the integral of v of t from 0 to 24. So notice how you're just integrating velocity, okay? So you should know that this is your displacement, not distance, okay? And be careful with the scoring guidelines, because sometimes they'll use it interchangeably, because sometimes displacement is the same as distance in some cases. So don't be fooled by it, okay? So you're going to say that this is the displacement of the car. Okay, now how do we measure displacement, right? Or yeah, displacement. How far did the car move, right? So in this case, we're looking for some type of units in distance. So we're just going to say meters. In meters. From t equals 0 seconds to t equals 24 seconds. The reason why I emphasize meters and seconds, it says is use correct units, okay? Now, let's take a look at the scoring guideline. They might write something different, but we're going to see here, 2005. Not that one. Okay, Here we go, the first one. Okay, so here they actually did a triangle, a rectangle, and another triangle. They cut it up into 3 different pieces, okay? Doesn't matter, equal is equal. They went all the way through, but I don't know why, right? Because you don't need to. What does it mean? The car travels 360 meters in these 24 seconds, okay? Definitely not what I wrote down, but it's the same thing. The displacement of the car is how far the car traveled, but they're going to give you a point for saying that it travels meters in the duration of the 24 seconds, meaning with units, okay? And again, it's a 2-point question, not that bad, okay? Very doable. So try it out. Let me know how it goes, and we'll go from there.